right, so now we want to get a sense of the spread of our raw data. So obviously the average isn't the perfect representation of the data. I mean, this is what we think is close to the actual value based on the measurements we did in lab, but there's obviously some uncertainty here. So standard deviation represents that uncertainty, all right? So in these boxes here, we want to calculate the standard deviation, which is essentially the uncertainty of this average, okay? And when we get the numbers, we'll talk about it a little more. So just like you did with average, you're gonna highlight the box, click function, that should bring up these functions for you, and you're gonna want to select standard deviation. If it's not in your list, you might have to search for it. It's STDEV, okay? Double click that and then it will ask you, well, what numbers do you want the standard deviation for? And you're gonna have to go back over here and select those same numbers for time 0 again and click enter, and there you go. We got a value of 2. So this is saying that our average suggests that 14.4 is close to the real value at time 0, but the standard deviation is saying that it could be 1 millimeter, or I'm sorry, 2 millimeters higher than that. It could be as high as 16.4, or 2 millimeters less than that, as low as 12.4. So it's saying, based on the data that we collected, it could actually be a bigger dicircle or a smaller dicircle base, for what we have so far. So there's this uncertainty. This number is a good estimate, but it's not the true value. It's our best guess within this range of 2 above and 2 below. And you'll see that in the graph too, and I think the graph makes it even more clear. Okay, so let's move on to time 10, the 10-minute mark, and I'll just do the whole process again for you. So click in the box that you want the number to appear, click function, choose standard deviation, double click it so that it asks you, hey, what numbers do you want the standard deviation for? And then you go over here and you select time 10, right? So 10 minutes, all of the values are selected, they're all highlighted, and this is the standard deviation. So you can see for the 10-minute time point, there is less uncertainty. We're more confident about this average width. It's closer to the real value because the standard deviation is lower, right? All right, so just like we did with the average, we can also use that special trick where we go to the bottom corner of the calculated box, and then we get the plus symbol, we can click and hold and drag down and get all of the values. So here you can see that there is based on our observations in class, there was the most uncertainty at the beginning of the experiment, but then as the experiment went on, our observations were more similar to one another, closer to one another, right? And you can also see that the standard deviation is, pretty low here, being around 1 versus our average width, which was, in the 20s. So that suggests that, we were all collecting data that's pretty similar. All right, so I'm just going to quickly fill in the rest of this. the average and the standard deviation for potassium permanganate, then I'll talk about the t-test a little. So here we go. Okay, so I'm clicking in the box that I want the average to appear. I'm going to click the function key. That should make this pop up. I'm going to select average, double click on it. And I'm going to go over. We're working on the potassium permanganate numbers now. So make sure you're selecting those. Once they're all highlighted, I'm going to click enter. And then just to speed things up, I'm just going to use that tricky fill in trick. And you can see there's the averages at all the time points. And in your discussion, you're going to be, comparing these two to see if there is a difference or not. All right. Okay. So let's do the same thing for standard deviation. Highlighting the box, click function, standard deviation. Okay, so once again, I want to select the right numbers. So we're still working on time 0 for potassium permanganate. They're all highlighted. Enter. So here's our standard deviation. Fill down. And you can see that the standard deviation is similar to what we got from malachite green. And this, this standard deviation, at least for the later time points, is right around, 5% or so, since the value is 20 and the measured average is 20-ish and the standard deviation is about 1. That's about 5%, and that's kind of what you see. Like 5% is this standard, variability. You see that a fair amount. If it was a lot higher than that, then we might be a little concerned. But this is reasonable. This is kind of what you would expect for variability between observations.